All right, let's see how we're doing. If you're ready, I can take what you have. Amazing. Just 30? You can get lucky?
my luck is.
They're still rolling the dice. All right, if you're still enjoying this quiz, you might have just missed it's like a guessing game, so if you can't quite get it, it's okay. I'll take what you have, and if you're doing it right, I'll give you most of your points. Yeah, you can go right back to the bigger region. Okay, I got it. Who else? You got something? You did something. Yeah, you got the whole thing. One more. Oh, it's so close. Let's see. I'm curious. Sounds like you're super close.
He mixes that inside.
Oh, I see. I see what you've done. Yeah, I understand what you did. Yeah, you just cut us. It's okay. I understand. Put the last, at least a C on there so I can emphasize. Yeah, I understand what you did. Yeah, it's just your starting point. Yeah, I think I got them all. Why is this not? Just a sec. Yeah, I don't know where the... Okay. So I'll show you what I got. So I did it on the computer because I was lazy. You don't want to have to do all the calculations myself. So here's what I've got. And but I can do this with any divisor you like. This is the divisor I used. And these are the 71, 28, and 1 were the numbers that I ended up with. But this works with there's a bunch of different divisors that work. 282 works. 283, I know. 283 works. I think someone had 282.5. But the trick is that you want to figure out what the standard divisor is. And the standard divisor is always the total population divided by the number of seats that we're dividing up. And so 285, that should be your starting point. So you were just starting way too low. And you had the right idea though, so you're in good shape. So the starting point should be about 285. And so if you did 285, here's what you'd get. You'd say, oh, you only got 99 seats instead of 100 seats. And so then you just have to make a slight adjustment to get this to work. Okay, so I don't know if you've noticed this. It might be hard to tell exactly what's going on with Jefferson's method, but Jefferson's method favors larger states. There is no way that the extra seat, remember there was only 99 when we did the standard divisor? There's no way that that extra seat would ever go to a small state. It generally goes to bigger states. So here it went to this, I think that state, where, let me do the standard divisor again. 285. Okay, it must have gone to the middle state, but the middle state is the one who ends up getting the extra seat. So, so generally, you find that this method favors larger states. And because of this, it only was used for a few times, like there was the very first apportionment in 1790, the second apportionment in 1800, and I think that was it. I don't think it was used after that because of this seemingly unfairness, and it was pretty obvious that the bigger states always benefited from Jefferson's method, and smaller states didn't work out as well for them. On the other hand, if you imagine trying to do something else, do something like Jefferson, but maybe round in a normal way, like round the way we expect to round, that would seemingly benefit both big and small states, because you're sometimes going up and sometimes going down with your rounding. The reason mathematically that this favors big states is because as you change the divisor, that's going to affect this quota much more than it will affect this quota. In fact, let's go ahead and just do this with the numbers that are up here. You can see that as I change the divisor, it's 285. If I change to 284, notice that, so I won't hit enter yet, but right now we have 1.05 and 71.05. So 1.05, 71.05. When I change to 284, it's still 1.75, but notice the big state. It turned into 71.30. So you don't have to understand the mathematics behind this, but it's just a fact that mathematically, Jefferson's method ends up inflating the bigger states, and the small states generally don't get as many seats as they might deserve. And so this next method was devised by Daniel Webster, and it was sort of an attempt to make Jefferson's method a little bit more fair. And it was actually used off and on throughout the 1800s to apportion the House of Representatives. So let me show you what that looks like once I figure out how to do this. This is called Webster's method. So Webster's method, we're going to use the same numbers here, and we're going to use a house size of 100. So the size of the house is 100 seats. So let me just put Webster's. I couldn't locate my PowerPoint for some reason. It's probably right there, and I just am not seeing it. Here, let me see. Let me try one more time. Let's see. Hold on a sec. Come back to me, Webster. Oh, Adams. I've got Adams. Whoa, there it is. There's Webster. Okay, it's here. That's all right. We'll still do this one example that I have up on the screen. But let me just put this Webster's method. There's Webster's method. Use trial and error to find a modified quota that results in rounded quotas that add up to the proper numbers. So notice that we're going to round in the normal way. Don't round everyone down. Don't round everyone up. We're just going to round the normal way. The normal way is if it's 0.5, you go up. If it's below 0.5, you go down. So let's actually do this with this particular example, the one with the that you had on your quiz. So I'll switch back and forth here, and I've got another example on the PowerPoint that I can show you. But this one, since now everyone's in the same position, we can do this. Let's use the divisor. And here, unlike Jefferson's method, the standard divisor might work. So sometimes the standard divisor works, sometimes it doesn't. The standard divisor is, let's see, the total, which was 285.00. So the standard divisor is the total divided by the number of seats, 285. So let's actually try this. I'll do this on my calculator, although I suppose we can have the computer do it, but let's go ahead and do this using the calculator. 250 divided by 285 is 71.05. Let's see, 7950 divided by 285 is 27.89. And then 300 divided by 285 is 1.05. So remember, what we're going to do is we're going to round the normal way. That means that this guy, or the mathocrats, they round down because 0.05 is less than 0.5. The biopticians, they round up because 0.89 is bigger than 1/2. And then the communists, they go down. Let's add those up. So it's just like Jefferson's method. We're going to use trial and error, but instead of rounding everyone down, you round some people up or down depending on how close they are to 0.5. So this becomes 100. Hey, we did it. Okay, so that time the standard divisor worked. So when you're doing Webster's method, you're just going to use trial and error. Sometimes always start with the standard divisor, and then you might have to pick a bigger number, you might have to pick a smaller number. Let me switch over to the PowerPoint so you can see this in action where it's a little bit more interesting perhaps. So here again, the important stuff is, I think we had this last time, this actual set of numbers. But the important stuff, and maybe I'll put this up on my iPad. The important stuff are the 4 states, or it's not states, it's departments. So we're apportioning faculty members amongst 4 departments. So I'm going to put those 4 departments up here. On my iPad, I'll put it up there once I have it. There's biology, computer science, math, and physical science. Give me a sec here. 50, 81, 124, 20. And then the quota, this is with the divisor, equal to 15.27. Almost done. Okay, so let me just show you what I've got here, so you can see. I know my grid looks not as good as the PowerPoint grid, but that's okay. So what I'm going to be doing is I have the divisor of 15.27, and where that came from was I actually took 275 divided by 18. This is the standard divisor. Always start with the standard divisor with Webster's method because sometimes you're going to get lucky. It will work. Anyway, I have the numbers. I can see them here. I'll copy them. If you didn't copy them, it's okay. The biology had 3.27 as its quota. Computer science was 5.3. Mathematics was 8.1. And then physical science was 1.3. So Webster's method says round in the normal way. Now, when you look at this, you say, hey, we're going to round the normal way. And the normal way means that everyone below 0.5 goes down, everyone above 0.5 goes up. And so the rounding, after rounding, you get 3, 5, 8, and 1. And when you add that up, you get a total of 17. So that was too few the same rules apply for finding a new divisor. So we're going to pick a new divisor. We've apportioned too few, so let's pick a divisor of, sorry, I'm going to do this here. Apparently 14.6. So apparently if I had tried using 15, that probably wouldn't be low enough. So I won't bother with 15, but here's the 14.6 situation. And once again, I'll copy it over, don't worry. So 14.6, and it might take a little bit of hunting around to get this, but with 14.6, the quotas, put this in a different color, the quotas end up being 3.42, 5.54, 8.49, 1.37, I guess that's it. And then rounding, you're going to round the normal way. And that does add up to 18. So you know how with the, well actually it just depends. I was going to say that this may take a few more tries than Jefferson's method to find, but you might get lucky on the first try, or maybe the second try. But it might take 3 or 4 tries to figure out what the correct answer is. Let me see if I have this. I don't want to do that. Okay, we'll do this. Just for fun here. Okay, so you remember, oh, this is Jefferson again. Yeah. All right, well, okay, I guess I can show you this nonetheless. This is back to Jefferson just briefly. It's just kind of interesting that that here are the, I wouldn't copy that down at all. You can always watch the video and relive the magic for today. But these are the actual populations for the states, and the actual quotas. This is the actual Hamilton's apportionment, and then this is the apportionment that is Jefferson's apportionment. And so you can see that the main difference, Virginia ended up getting an extra seat, and who lost out? It must be some small states. Here, there's that one. Maine has fewer under Jefferson. Someone else must be a winner. Why is this? Just a minute. We have 2 states. Oh, here it is. Massachusetts gets 1 more. So, interestingly, Maine and Massachusetts. So Maine, what's the deal? Maine didn't become a state until after, I think, after the first apportionment, but before the second apportionment. And so it just depends on how Maine, how this is. But back before Maine was a state, Maine was part of Massachusetts, which is weird to think of because you have New Hampshire in between Maine, like there's another state in there. So you have Massachusetts and then more of Massachusetts up above. So I think the same deal was with Virginia and West Virginia. Yeah, this includes West Virginia, current right here, but in future apportionments. I don't know when West Virginia became a state. It was the West Virginia Territory, I think. You know the answer?
I think it's the
Civil War was when West Virginia became a state? That late?
Because they seceded from Virginia because they didn't like slavery.
I didn't know that.
If you think about a lot of the young slaves that were in like past houses and stuff,
Okay.
that's what it's like.
All right. Okay. Interesting. Yeah, I don't know my West Virginia history. Thank you. You guys know it better than me. But anyway, so there it is. There's those. Now, the problems and paradoxes that could occur, we've already gone over 3 of these, but there's a new one at the bottom that we need to talk about briefly, and then we'll take a look at homework. And because I don't know that I could try to come up with an example for this quota rule, but it might be easier just to use one from the homework to see the quota rule. So you already know about the Alabama paradox. This is if you change the number of seats being apportioned, then some state either loses some its apportionment. Population paradox, states population increases, and yet they lose seats to a slower growing state. The new states paradox, that's when you have a new state. Those three only occur with Hamilton's method. They don't occur with any of the other methods that we were looking at. And so the quota rule, though, you might think that, well, then these other methods must be great. Well, the quota rule is something that occurs with all other apportionment methods, not Hamilton's method, though. So let me explain briefly what we mean by the quota rule. Let's see, we can do this in terms of this problem right here, I think. Yes. Okay, let's do this in terms of this problem right here. So, here's what the quota rule says. Let me just erase some of this so that I can make room for the quota rule. Give me a sec. We'll get rid of this stuff, get rid of that stuff, and this stuff. Okay, so the quota rule says that it seems like it would be only fair if states would only get either their lower quota or their upper quota. That's what the quota rule, that's all it says. And so, in other words, what would be fair, so we'll put this here, fair. Fair would be getting either your lower quota or your upper quota. You might think, well, how could you get something other than that? Well, I'll show you an example, hopefully, in just a minute. But so fair is either lower quota or upper quota. So in this case, biology should only either get 3 or 4. They shouldn't get 5, they shouldn't get 2. It's either 3 or 4, not 5 or 2. Same thing with CS. CS should either get 5 or 6. Notice what I'm doing here is I'm taking the standard divisor, and the standard divisor is what you get with Hamilton's method, getting the normal divisor, and or the standard quota, sorry. Standard quota comes from the standard divisor. This one, either round down or round up. That's what would be fair. So either 8 or 9. And then the last one, either 1 or 2. And that's it. Those are the only ones that would make sense in terms of the math here. So let me see if I can concoct an example that violates this. It'll just take a sec. Give me a minute here. I'll pull up this. So this is my cheater spreadsheet, and I need to be able to see it on both screens. So let's see. Over here. Come on, buddy. Okay. So here I've got an example with 6 states. So we'll just call it A through. And we can ignore what is going on here. Rides, quota. Okay, so I'm going to just make one up where I have, let's say, 10,000 here. And then let's go with 300. No, we need more than that. 1,000. 1,000. Give me a sec here. 1,000. 1,000. 1,000. Okay, so this is a really boring example. Ignore those quotas for just a minute because I'm going to have to change this divisor. Ignore the quotas. They don't make any sense right now. So imagine this situation where this is a route with rides. You can ignore the rides, and route thing can be, it's just states with their populations. And so the total, there's 15,000 people in this particular country. Or maybe it's 15 million, maybe these are thousands of people, it doesn't matter. So you have 15,000, and I want to apportion, just a minute here, I want to make sure that this works out right. I need 15 times 345. I need this to work out divide by 3. Yeah, I think 45. Will that do it? We're going to find out. So let's say that we have 45 seats. So the total is 15,000, 45 seats, and we'll do 15,000 divided by 45 is the standard divisor. So divisor. So this is math that you do on your calculator. And so when I do this, I get 15,000 divided by 45, which is 333.333. Did I do that right? 333.333. I did not. What do I want to do here? I want 3.33. That's what I want. Okay, so I think I want 50 seats. Let's try 50. Yeah, see, it's the right problem with trying to do this on the fly. 50 seats. Let me see if this works. Give me a sec. 15,000 divided by 50. What do we get here? Equals 15,000 divided by 50. 300. Yeah, this is going to do it. Okay. So standard divisor is 300. You can ignore these numbers down here. They are irrelevant at this point. It's not all been erased. 3. Okay. So looking at these, if we have 50 seats, divisor is 300. These are the standard quotas for each of these. So let's talk about the lower quota and upper quota for each of these people. So first of all, state A, lower quota would be 33, upper quota would be 34. If we did state B, lower quota would be 3, upper quota would be 4. And that's going to be the case with every one of these. So now we can sort of simulate this. So in other words, what would be fair is for this state to get between 33 and 34 seats, according to the quota rule. This would get 3 or 4, and all the rest of them would be 3 or 4. So now we can put back in this round down, what is this, the floor function? Let's see if that works. No, it doesn't. Just a minute. What does it say? Oh, significance. Let's see, does that do it? Divide by 0? What's wrong with this? There we go. Okay, round down. And that's what we get when we round everyone down. So since we only got 48 seats, we need 2 more when we round everyone down. So let's make the divisor smaller. So let's change from 300 to say 290. Now we've got 49. We need to get it even lower. Let's try 280. There, I did it. Okay, I'm in good shape, right? Well, what do you notice about state A? Look at state A. It ended up with more than its upper quota. So this is what's called a violation of the quota rule. So on your homework, what you're going to do is you're going to work out your problem, you're going to finish the problem, and then it's going to ask, have you violated the quota rule? When you get to that point, and I'll show you an example of this from the homework in just a minute, but when you get to that point, you need to go back and ask yourself, well, what was the upper and lower quota? And you might have to go back in your work and see, well, with the standard divisor, this state has a standard quota of 33.3, which means they should either get 33 or 34. And in fact, they end up with 35 seats. Let's go ahead and see what this looks like in the homework. Look at that. The homework due date has already been reached. Well, that's because that was for today. Give me a sec. Here, so Webster and the quota rule. So Webster isn't going to be too difficult, hopefully. But here we go. Where's the one? Does this situation illustrate any apportionment issues? Jefferson's method. Yeah, this one should be good. Okay, so for this one, Why don't I do this one on my computer just because, oh, and by the way, here we go. I guess I need to be able to see both of these at the same time, so I'll need to move this one over. Give me a sec. Yeah, by the way, if you want to write your own code for a spreadsheet, you can go right ahead and do that. Nothing wrong with it. I mean, to help you with the homework. Okay, so let me type in these numbers. You probably have something slightly different for yours. But I just wanted to help you figure out how to answer this question. Does this situation illustrate any apportionment issues? If it says apportionment issues, if it's Hamilton's method, it'll either be the new state, the population paradox, or Alabama paradox. Those are the only three. And if it's not Hamilton, then it'll be the quota issue, or maybe not the quota rule. So it'll be either the quota rule or not the quota rule. I'm going to just type in these in my spreadsheet here so I can do them quickly without having to pull out a calculator. 56600, 27800. Oops. And 149300. Okay, and then what is it that we're doing? We're doing this equals that. How many? It doesn't say how many. Oh, 92. 92. Okay. Okay, so let me explain what I've done up here. Oh, it's on the screen. I need to move it over. So here's what I've got with my handy little calculator. Zoom in just a bit. So I've got the different states. Oh, I need to get that fixed. Just a sec. Okay, that's better. So I've got the different states, and I've got their quotas. So there's the standard divisor. The standard divisor is the total population divided by 92 that I just copied up there. And then I've got their standard quotas, and I've rounded them all down. Now, before I go on, and this especially so that we can answer that question about the issues, we might want to do this. Just jot down that this state should either get 60 or 61 according to the quota rule. In fact, maybe I'll just jot this down right here. This will be quota rule. This state should get either 7 or 8. This one should get 3 or 4. This will help focus us when we answer that question. This is 19 or 20. Now we'll do Jefferson's method. Jefferson's method says we're rounding everyone down, which is what I did here. I rounded all these down. You can see 60.8 became 60, etc. And I ended up with 89. That's low, so I need to reduce this to, say, 7,300. Oh, I got it the first time. Yeah, nice guess. So, yeah. Yeah, so you might get lucky. In fact, that's so nice if you do. Pick a number, and especially since you're using your calculators, unless you want to write a little spreadsheet like this. And then round everyone down, and we got 92, so I'm good. So there's my answers. Let me go back here and type them in. We got 62,730. Oh, sorry, I need to explain. Let me undo that for just a sec. So the initial allocation, I think, refers to those numbers there, your standard quota rounded down. Let me check, though, make sure that I know what I'm talking about. Yeah, it looks like that's the case. See, 67, 3, and 19. So that's, in fact, what we have here. And then the, how do I do redo? There it is. The actual Jefferson's method, you would do this, change your divisor until you get things to work out. And we have 62, 7, 3, and 20. So 62, 7, 3, and 20. I'm just clicking the little key there because I know I know I'm right. Now, as far as the apportionment issues go, the only apportionment issues that would have the population, Alabama, or new states paradox, the only thing would be Hamilton. So Hamilton would be one of these three. So since this is not Hamilton, this is Jefferson, it'll either be a quota rule violation or not. And to check to see if it's a quota rule violation, here is the quota rule. And we want to compare the quota rule with what we actually got. It looks like we're okay here, and we're okay there. But this one violates the quota rule. It got too many seats, at least according to the quota rule. So this is a quota rule violation. So when you do this yourselves, you'll probably get a quota rule violation for the first one. You probably have different numbers. But I guess I can just click that and you can see, look, quota rule violation. So the other one, same deal. Notice Hamilton, Jefferson, and Webster. You can do all three of them. Do they fail the quota rule? It's not going to be Hamilton, by the way, because Hamilton cannot fail the quota rule. So don't check that one. It'll either be Jefferson, Webster, maybe both of them, maybe none. So you can work that one out on your own. By the way, you might get worried about this question here. You see this where it says which of the apportionment above would use, blah, blah, blah. It says answers will vary. And I think whatever you type in there, type something intelligible, but I think whatever you type in there, you'll get it correct. Or maybe I have to go and read them. I forget how that works. But you can type something in there that's semi-intelligent. And then there's a few others here. There's some Webster's method. So there it is. Okay, so just a quick brief history, and then we'll get out of here. So as I mentioned, we have Jefferson's method that was used in 1790s, 1800. Then Webster's method and Hamilton's method were used back and forth. Sometimes Congress chose their house size to make sure that Webster and Hamilton agreed, so that they wouldn't have to choose. But you go back and forth through the 1800s. Early 1900s, Congress got really sick of Hamilton's method. I think 1900 was the last time, maybe 1910, last time it was used. And eventually, in 1945, Congress passed a law to institute what's called the Hill-Huntington method. Now, all these other methods were named after Congress people or politicians like Webster and like Hamilton and Jefferson, but Hill and Huntington were statisticians. They got together and said, how can we do this right? And they did it right. In fact, they did it so right that that's the way that we use nowadays. It is very similar to Jefferson's and Webster's method, but it's got a slight tweak to it that we'll talk about on Monday. For now, though, look, we're done a little bit early. I will have, hopefully tomorrow, we'll have a practice exam online for you for next Friday. So you can get started on studying, hopefully by Monday. Otherwise, you just have this short assignment for the weekend. So hope you have a good, you're gone. Yeah, you can go.
Sorry, I'm
Yeah.
exercise.
He wants to get out in the snow. Enjoy.